So first thing I want to do here before we do anything else, I mean, I'm going to answer questions and all that kind of stuff, but I want to talk about next week's schedule, and I want that on the first page here because next week's schedule is definitely different than a typical week because it's a test week. So so let's see. So first of all, let's go through Sunday. We're going to go through this day by day. So Sunday, and that's the 24th. I have office hours, online office hours that day. And that goes from 7:30 to 9 p.m. By the way, my Sunday office hours, when I set this schedule up at the beginning of the semester, I thought that my Sunday evening office hours would be very popular hours for students to come on by. And so far, I'm trying to think, but I don't think I've had anybody attend an office hour on Sunday. During the week I have, but not on Sunday. So I'm not gonna. I'm gonna just continue to run those like they are, but don't hesitate to take advantage of those. So, and then in this class, Monday, the 25th, your Chapter 7 web assigned homework is all due. And that is 7.1 through 7.6. Yeah, 7.1 through 7.6, and that's due at midnight. So, you've got all day on Monday to be finishing it up. And from what I've seen, a decent number of students, just in general in my class, have gotten most of the Chapter 7 homework done. As I go through and help students with WebAssign homework, WebAssign is frankly maybe not, for me at least, not the greatest homework assignment software in the world. And so one complaint I have about it is that frequently, and my guess is you guys have this complaint also, is that the numbers on some of these problems get to be kind of big. That's okay. Certainly use a calculator to work through them when you're doing that on WebAssign, but make sure you know that on the exam that the numbers won't be anything like that at all. So it'll be very reasonable on the exam as far as how big the numbers are and everything. So I just wanted to kind of allay your concerns about that. So, and then on Tuesday, the 26th, let's see, so that's live lecture from 9 to 10:15. And on that day, we are going to cover sections 8.5 and 8.6 in your and then I have also on that day I have office hours from 1 to 2 o'clock. 1 to 2 p.m. online office hours. Okay, and then after that, the schedule.
I have a question.
Okay.
I'm sorry.
No,
but when you're doing online office hours, do we log into here?
Yep.
Okay.
Yeah, just do exactly the same thing, Michelle, that you've been doing for a live lecture. You just go to the WebEx room, and I will be there.
Okay, thank you.
And let me point out, like yesterday, last night, I had a couple of students show up at the beginning of online office hours, and we spent probably 30 minutes talking about problems out of the textbook and things like that. Last week, I had a couple of students from my college algebra class show up at the very beginning of my hour with them, and I spent the whole hour with those two students working problems. So, that's just like face-to-face office hours. That's a great opportunity to stop by. In this case, stop by my my online room and ask some questions. And if you have concerns about the class, that's a time to do that. Um,
Okay, thank you.
oh yeah, and then it gets really different after that. So Wednesday, the 27th. I typically have online office hours. I don't have online office hours. I will be on campus that day. And remember, that's the North Harris campus. My office is Winship 115K. And right now, I plan to be in my office from 4 to 6 p.m. That evening. And if there's students around at 6 o'clock, I will stay after 6 also and continue to work with people. And then on the Thursday, the 28th, two things. First of all, the exam 1 window opens on that day. And so remember now, this goes through October the 3rd. And so that's any time between the 28th and the 3rd of October. You can go to any of the testing centers in the Lone Star system and, make sure you have a student ID with you, and you can take my exam. You'll just need to know what my name is and what the section number is and your photo ID, and then they will have a copy of the test. You should allow yourself about 2 hours to take the test. And so that means show up with at least 2 hours left on the as far as when the testing center is open. So like if the testing center is open until 8 o'clock in the evening and you show up at 7 o'clock, well, you've only given yourself an hour to finish the exam, and that's just not enough time. So if it closes at 8, you get there by 6.
What do we do if, like, say, for example, the college center, their ID machine is still down? Because I'm closest to Greens Point, but since I haven't enrolled, the ID system has been down, so I don't have an ID.
Michelle, you ought to be able to take the test with your driver's license. So
Okay.
just as long as you have a photo ID with you, and so and if you don't have a student ID yet, if you have a way of getting up to the North Harris campus and getting an ID made, that would be ideal. But if you go and just have a driver's license, they'll let you. What they'll do is they'll check and make sure your name is on the roll for that class, and they'll let you take the test. So as long as you have a photo ID like that, you're okay. So. Okay. And let's see, what else do I need to tell you about the test? The test, remember, is just a paper and pencil test. It's not taken on WebAssign. And so, you'll just take the test just like in any other test. You'll show all your work. I will try to leave a substantial amount of room for you to work to show your work. There's been issues with scratch paper from various different testing centers, and so I'm going to say no scratch paper at this point, but I'm going to give you lots of room on the test, so you should have a lot of room to do your work. And then you can always use the backs of one of the other pages if you really need to do some kind of figuring. Let's see. I'm writing the test so that most people should be able to finish the test in 90 minutes. The fastest people will get it done in probably 45 minutes to an hour. And most people should be done in 90 minutes or a little bit less than 90 minutes. So the 2 hours, I'm going to put a 2-hour time limit on the test, but that should be plenty of time for you to take the test. So don't panic about the test at all. Also on the 28th, I'll be on campus again on that day. And I'll be on campus from 9 to 11 a.m. in the morning. So I'm going to actually highlight both of those because I want to point that out, that I'm on campus available for face-to-face help those days. So make sure that you take advantage of that if you can, okay? And then the following week, let's see. So you have, that's the following. And by the way, notice on Thursday then, because there's the exam one window's open, I'm on campus, no lecture that day. Right, so no lecture on that Thursday. And then the following Tuesday, October the 3rd, again, because it's a testing window, there's not going to be any live lecture that day either. That's on your calendar, but I just wanted to kind of remind you of that during test weeks, we typically skip live lecture on those days. So I won't be, just like in a class setting where, I might be just reviewing, it's kind of the same thing there. So, okay, and then after that, then after the 3rd, then we resume a normal schedule after that. So, anybody have any questions about that stuff before I go on? Are we okay with that? Everybody?
I'm good.
Everybody's okay?
Still good.
Yes, sir. Everything's good.
Okay. All right. Then today, we're covering, and make sure I get the section numbers straight here. So today we're covering section 8.3 on addition and subtraction. So today's our addition and subtraction day. And remember what we're talking about. We're talking about adding and subtracting rational expressions. Last time we talked about multiplication and division of rational expressions. And then we're also talking about complex fractions, which is a special type of rational expression. And sometimes they're called complex fractions, sometimes they're called complex rational expressions. And we'll talk about simplifying those kinds of expressions. All right. Then next week we talk about solving equations that have rational expressions in them. And this exam will cover up through equations. There are some word problems at the end of this chapter, but none of those word problems will be on this exam. Okay, just so you know. All right, so addition and subtraction of rational expressions. So remember, with multiplication and division, it didn't matter what the fractions look like. You could always multiply and you could always divide, right? So A over B times C over D was just A times C over B times D. It didn't matter what the denominators look like. You could always take any two fractions and multiply them together. And the same thing with division, right? We know this little, we have this little leave, change algorithm here, and it still ends up being just a multiplication problem. So you can multiply or divide. So you can multiply or divide any fractions. Didn't matter what they look like. Addition and subtraction, that was different, right? And so you know that. That addition and subtraction, what's got to be true? The denominators absolutely must be identical. And if they are not identical, you cannot add or subtract them. And that's obviously where the hard part of the problem comes in, is what happens when the denominators are not identical. What do you have to do, right? So we know that if you have A over B plus C over B, like that, right, denominators are the same. And this would be true for subtraction also, that what happens here? The denominator is unchanged, it stays B, and then you just have A plus or minus C in the numerator. In other words, you just add the numerators, the denominators is the same. So if you have 5 6 minus 11 6, let's say 13 6, that since the denominators are the same, you can subtract those, right? And you get just 5 minus 13 in the numerator. And so then you get negative 8 over 6, or negative, and then simplify it at the end, and you get negative 4 over 3. No big deal. This is something that you should be fine with. Now, if the expression's a little bit different looking, so if it's got variables in it, no difference here. So if you have 3x over x plus 4 minus 7x over x plus 4, right? The denominators are equal. And since the denominators are equal, you can go ahead and combine those. So you get 3x minus 7x in the numerator, and then you have x plus 4 in the denominator, right? The denominator doesn't change, just like the problem on the last page, and then you just subtract the numerators. Those are like terms, 3x minus 7x, and that gives you negative 4x over x plus 4. And then remember, don't you dare cancel those 4's, right? Because the 4 in the denominator is a term. You cannot divide those out. You can only divide out factors. We talked a lot about that last time in our lecture. And so I can't divide those 4's out. And so that's my simplified answer right there. There's nothing else I can do with that. Okay, so that looks okay. Not a big deal. But you have to be careful when you're talking about subtraction, especially even if the denominators are the same. You have to be really careful. So let's look at this problem. Let's say we have let's see, 5x right there and an x right there, and let's say I have plus 9, and then over here I have that this is plus 3, like that. All right, denominators are the same, so I can subtract them. The problem is that if you write it this way, let me write this down right here. This is wrong right here, what I'm about to write down. This is very common to see students write it this way. It's 2x plus 3, and then in the numerator you have 5x plus 9 minus x plus 3, like that. That is absolutely incorrect to write it that way, and I've made a mistake there when I wrote it. And let me ask you, does anybody know what the mistake is right there?
Is it because you did put parentheses?
Very good answer, Michelle. Very good answer. And you're exactly right. There's got to be parentheses. And the problem is that what you have to do, now the 5x plus 9 is not a big deal really, but the x plus 3 is a big deal. You're subtracting the entire expression x plus 3. But that's not what this person is doing who wrote it incorrectly. They're just subtracting the x, but not the 3. You have to put parentheses around that x plus 3. And then when you do that, what happens? You distribute that minus sign through, right? That's like a negative 1 being out there, where you're taking the opposite of x plus 3, however you want to think of it. And so that gives you negative x minus 3, or minus x minus 3. See, and so that's different than what the person did before. So for that reason, because that is absolutely one of the most common mistakes I see students make. Whenever I see a subtraction problem, and these kinds of problems with addition and subtraction, when I see subtraction, I call this a red flag problem. And I actually kind of draw, that's my red flag right there. I actually wave a red flag when I see a subtraction problem, and I actually draw out a red flag just to remind myself, hey, I could screw up the signs here if I'm not careful. And I actually say that to myself. I could screw up the signs if I am not careful. And And so that red flag is kind of a warning flag, right? That's a typical red flag situations where you have a warning here, and you're warning yourself to pay attention to the signs here. I actually have students all the time. I go through and I grade their tests, and I can see little red flags or little flags of some type drawn on problems like this just to kind of remind themselves of that. It may sound like a goofy thing to do, but I think that's a great something just to kind of get your attention that this is a potential place where you could screw up the signs. And remember, this only occurs in subtraction problems. So, addition problems, you don't have to worry about the signs, but subtraction problems, you got to worry about the signs. All right, so now let's go back to the problem here. I have some like terms to collect in the numerator. So I collect them. So 5x minus x is 4x, and 9 minus 3 is 6. And then I have 2x plus 3 in the denominator. All right, now I am still not finished with that problem. Does anybody know why I am not finished with that problem?
Can you simplify that?
I can simplify. Very good. You are on a roll today, Michelle. And so how does it simplify? What should I do to simplify that?
When you divide the denominator by the numerator?
No. Not exactly. Remember how you simplify a fraction. Remember what we've talked about in the last section, that you try to factor everything, right? And there's a common factor in the numerator of 2. And so you have 2 times 2x plus 3 in the numerator, and you have 2x plus 3 in the denominator. Maybe that's what you meant, Michelle. I'm not sure. But you can take out a 2 out of the numerator, and when you do that, then I'm left with a common factor, right? The 2x plus 3's now divide out because they're common factors. And then I'm left with 2 as my answer. All right.
Why didn't you take out the common factor in the denominator?
Well, there is no common factor in the denominator. If there was one, I agree, I would do that. Yeah, but 2x plus 3 doesn't have a common factor, so there's nothing to take out there. But Anne-Marie, if there was a common factor, absolutely, I would factor that also. So, all right, so let's look at, let's see, I'm in your textbook, and I think I have the section numbers kind of incorrect when I wrote some stuff out here, and so I'll have to apologize for that a little bit. I think I got some stuff out of whack here as far as this textbook doesn't lay things out like the last textbook I used, and so I got confused about something, but I'll talk about that in a minute. This is problem number 156. This is section 8.3, and this is problem 156, and this is page 921 of your book. So let's look at this problem. You've got 7t squared minus t minus 4 divided by t squared minus 25, and then minus 6t squared plus 2t minus 1 over t squared minus 25. Now don't freak out. I know it looks like a complicated expression when you see it, but we'll be able to deal with this. You see it's a subtraction problem. So when you see a subtraction problem, the very first thing you look at is the denominators. And what do the denominators look like, right? In this case, the denominators are the same. And so we can go ahead and subtract these two fractions. It's a subtraction problem, so I'm also going to think of this as a red flag problem, right? Because it's subtraction, and so that means I could screw up the signs if I'm not careful in the next step. So I combine these as one fraction. I'll just write t squared minus 25 in the denominator. In the numerator, this is 7t squared minus t minus 4. And then this is minus, in parentheses, 6t squared plus 2t minus 1. Like that. And then why did I put those parentheses in there is because, right, this is going to distribute right here, and it's going to change all those signs. So always make sure that you put that second denominator in parentheses so that you remember to change the signs. So this is minus 6t squared minus 2t plus 1. And this is all divided by t squared minus 25. All right, and then you collect like terms. So make sure you collect like terms here, and make sure that you're only collecting like terms, right? The exponents have to be identical in order for you to add them together. So 7t squared minus 6t squared is t squared. Negative t minus 2t is negative 3t. And then negative 4 plus 1 is negative 3. Negative 3. Okay, let's make sure I was making sure I copied the problem correctly, but I did. And then in the denominator, this is still t squared minus 25. Now, what you would try to do here is you would try to factor that, and the denominator does factor. That's right, because that's the difference of squares, and so that's t plus 5 times t minus 5. But the numerator, t squared minus 3t minus 3, well, that's an easy trinomial. And see, there's no way we're going to get that middle term of 3t with a 3 at the end. And so we're done with this problem. Right, that's not factorable at all, and so that's my simplified form. So try to factor everything, see if anything cancels out. But once you've done that, then if there's no common factors, then you're finished with the problem. Okay, so let's look at, and please stop me if you have a question about something. So I guess we're okay. So let's look at number 158 next. You have 20w times 5w minus 2 plus 5w plus 6 over 2 minus 5w. All right, so this is a problem where and we actually talked about this a little bit last time in class. In this case, the denominators are not the same, but the denominators are opposites of each other. 5w minus 2 and 2 minus 5w are opposites. Remember, anytime you have one of them is a minus b and the other one's b minus a, you have opposites. Right? So a minus b and b minus a are opposites. And so anytime you have that kind of factor in the denominator, you've got opposites. So they're not the same, but there is a way to deal with this to make them the same relatively easily. And what you do is you simply, there's actually several ways you could look at this, but this is the way I typically do this, is I just multiply the denominator by negative 1. And when I multiply that denominator by negative 1, and I typically do that in the second fraction. It doesn't really matter which one you do, but what happens is if you think about that, the negative 1 times 2 would give you negative 2, and negative 1 times negative 5w would give you positive 5w. And so notice it turns it into the other factor, or the other denominator. So you get 5w minus 2 right there also. Now, the other thing you have to remember is, so I multiplied the denominator by negative 1. Don't forget that whatever you do to one part of the fraction, you have to do to the other part also. So what that means here is, I multiplied the denominator by negative 1. I've got to multiply the numerator by negative 1 also. Right? You have to multiply top and bottom by the same number, like that. And when I say whatever you do to one part of a fraction, I'm talking specifically about multiplication here.
Why are we multiplying by negative 1?
Because the two factors are, think about it for a second, Michelle. If you have two numbers, like 3 and negative 3, right? Those are opposites of each other, right? So what would I multiply the second one by so it looked like the first one?
Negative 1.
There you go. That's why. You want to make the second one look like the first one, and the way to do that when you have opposites is to multiply it by negative 1. So 5w minus 2 5w minus 2 and 2 minus 5w are opposites of each other. So in order to make them look the same, because they're opposites, I multiply one of them by -1 to make it look like the other one, right? So that's what we're talking about right here. You multiply one of them by -1. Let's see. So it looks like the other one. Okay. So that's exactly why you're doing that. Exactly like the 3 and the -3 at the top. But the deal is that whenever you do multiply the denominator by -1, you have to multiply the numerator by -1 also. And so what happens to the numerator? There, you're using the distributive property there also. And so what does that become? -5w minus 6, like that. And now the two fractions have the same denominators. And so now we can add these together. So you get 20w, and then you have plus -5w, so that's just minus 5w minus 6. Since it's addition, it's not a red flag problem, so you don't have to worry about changing signs or anything like that. And then that gives you 15w minus 6 over 5w minus 2. And then remember, you're not finished at this point because there's a common factor of 3 in the numerator. So you take that out and you're left with 5w minus 2. And sure enough, the 5w minus 2's divide out. There's a common factor there. And so you are left with 3. Left with 3 is the answer here. Okay, so we're going to work another problem like this. So don't freak out too much here. We're going to look at another problem with opposites in them. So let's see. So are we okay with this problem? We're going to look at another example similar to that. So does anybody have a question? Okay, I'm not getting anything, so that means I'm assuming everybody's sort of okay. So this is number 160. You have 6y squared plus 2y minus 11 over 3y minus 7. And then plus 3y squared minus 3y plus 17 over 7 minus 3y. Like that. And so you see in this problem how the denominators are opposites of each other. So the denominators are opposites. Remember, one of them is a minus b, the other one is b minus a. And so what do? We multiply the second fraction by, and what do we multiply? The top and the bottom both by -1, right? We multiply by -1 over -1. And remember, that's legal to do, to multiply by -1 over -1, because what is -1 over -1? It's really equal to 1. So all I'm doing is multiplying this fraction by 1, and that's okay. So, that's always, multiplying something by 1 is not a problem. So what do I do here? I multiply the top by -1 and the bottom by -1. And what does that do? That takes the denominator and it essentially turns the terms around and it makes them look the same, like that, right? And then everything else is unchanged in this problem. So remember to multiply through by this -1 right here. And so that's -3y squared plus 3y minus 17. All right, and so now the denominators are the same. And so this is 6y squared plus 2y minus 11. And then plus -3y squared, so that's just minus 3y squared plus 3y minus 17. Remember, again, this was an addition problem, so there's no reason to change any of the signs at all. And then you collect like terms. So this is 3y squared plus 5y minus 28. Minus 28, that's right. All over 3y minus 7. And then you do have to check to see if the numerator is factorable. And it might factor. We definitely need to check that. There would be a 3y and a y have to be the first terms there because those are the only factors of 3. And so the factors of 28 are 1 and 28, 2 and 14, and 4 and 7. And in fact, 4 and 7 work in this case. If I put a 4 in the second fraction and a 7 here, yeah, that's right. You're checking the inside 2 and the outside 2. And the inside 2 is 7y. The outside 2 is 12y. And you can get a positive 5y out of that, right? The 12 needs to be positive and the 7 needs to be negative. So sure enough, it does factor. And then the 3y minus 7s end up being common factors at the end. And so we can divide those out, boom and boom. And we are left with y plus 4 at the end. Technically, y plus 4 over 1, because that's what divided out. And I didn't mention that in the last problem. I should have, I guess. But that's the same thing as y plus 4. So, okay, we're all right there. Okay, I think we're okay. Now, this is where I kind of made a mistake, and I'm going to maybe have to change some stuff here but at the beginning. But I need to go back to the second page here. I actually kind of got confused a little bit about the sections. And so 8.3 and 8.4, and 8.3 is addition and subtraction of rational expressions. I kind of forgot the way this book was set up, to be honest with you, so I screwed up here. 8.3 is addition and subtraction of rational expression where you have the same denominator. That's what we've just been talking about. And then 8.4 is addition and subtraction. So addition and subtraction where the denominators are different. And I forgot that was split up into 2 sections here. And so that's what we're covering today. We're actually covering less material than you thought. So that's good. But we're covering just addition and subtraction today where the denominators are the same and where the denominators are different. And then the complex fraction stuff, that's next Tuesday's lecture. So I kind of messed up there a little bit. All right, so let's now go on. We've talked about denominators being the same, and so now let's talk about problems where the denominators are different. Now we're going to talk about section 8.4. Different denominators. Okay, so with different denominators, one thing I want you to kind of keep in mind here is that go back to a simpler problem like you might have seen back earlier in your math careers, like 2/5 plus 1/6. Right? This is not, please do not ever tell me that this is 3/11. Right? You can't just add the numerators and add the denominators. Instead, what do you have to do here? You have to realize, hey, the denominators are not the same. So denominators are not equal. I must make them equal. Right? If they're not equal, then I cannot add or subtract in the problem. So what do you have to do here? You have to find the least common denominator. And so the least common denominator for 5 and 6 is the smallest number that they both divide into. Right? That's what you're talking about. Smallest number they both divide into. Now, the way to do this, the way to build that LCD, now probably all of you can look at 5 and 6 and say, well, hey, I know the LCD is going to be 30. That's the smallest number that 5 and 6 both divide into, which is fine for constants, but it doesn't work very well when you're thinking about it that way, when you're dealing with algebraic kind of expressions or polynomials. And so I want to show you how to do this with a small problem like this, and this will extend over into algebra also, to build the LCD. What you do is you take all the denominators and you factor them as much as they factor. So like 5 is not factorable, it's prime, so you just leave it alone. But 6 is 2 times 3. Right, it broke down a little bit. So to build the LCD, what you do is you just include every factor that you see in the denominators. Those have to be in the LCD, so you include all factors. So this is the LCD right here. Include all factors. And then you also, that's one thing. And then the other thing is you raise each to the largest power to which it appears. So when you have powers, you have to use that rule where you use the largest power. Now, that doesn't come up on this problem, but it will come up on another problem in a minute. So, so what do you have here for the LCD then? You have 2 and 3 and 5. Those are all the factors in the denominator. So you have to include all of them in the LCD. And so the LCD ends up being 30. Right, so that will always work like that. And then what you do here is then you multiply both fractions so that they have a 30 in the denominator. So the first fraction I'd multiply by 6 over 6. And remember, whatever you do to the numerator, you have to do the same thing to the denominator, and vice versa. You do the same thing to the top and the bottom. And the second fraction I'd multiply by 5 over 5. Okay? And so when you do that, you end up with 12 over 30 plus 5 over 30, and you get 17 over 30, right? You get the denominators are the same, and all of a sudden you can add them together. All right, so in the denominator, the moral to the story, when the denominators are not equal, you've got to make them equal. You have to find the least common denominator, and the least common denominator includes all the factors that you see in the denominators, and you raise them to the largest power that you see them raised to. So that power stuff did not come up on this problem because all the factors were raised to the first power, but I'll show you in this next problem what I'm talking about. All right, and then after this example, we'll look at a little bit more algebraic kind of problems here. So this next problem, let's say we have 17 over 25 minus 7 over, let's say we have 36. Or let's say, let's not use 36, let's use 54 right there. Now the numbers are a little bit nasty here, I understand that, but that's, but I'll show you how this kind of carries over to the algebra problems. So what about 25? How does 25 factor? How can I factor it?
5 and 5.
5 and 5. There you go. So instead of saying 5 and 5, because that's right, but we'll write it with exponents. That's 5 squared. Now 54, maybe you have a little bit harder time factoring it, but just find any factor of 54. So like 6 times 9 is fine. And then 6 breaks down as 2 and 3. And 9 breaks down as 3 and 3, or 3 squared. And so what do you end up with here? You end up with 2 times 3 cubed. And that's the factorization for that one. And so, you know, you could actually write these like that. That's 17 over 5 squared minus 7 over 2 times 3 cubed, like that. All right, so let's build the LCD. So to build the LCD, use all the factors that you see in the denominators. So the factors that I see are 2, 3, and 5. And then what do you do to those factors? You raise them to the largest power that you see them raised to in any of the factorizations. So 5 is raised to the second power. It's got to be raised to the second power in the LCD. And 3 has got to be raised to the third power in the LCD, like that. And so that's my least common denominator. It's an ugly number, but that's my least common denominator. It's 2 times 3 cubed times 5 squared. Again, don't worry about numbers that are this big on the test. I'm not going to do that on the test. I'm just trying to show you the method you're going to use to find the LCD for more algebraic kind of problems, okay? Now, so I think everybody's okay. Now, what do you multiply by in the original problem? Well, you multiply. This is the way I kind of look at this: is you multiply by the factor that is missing. And so this is what I'm talking about. So like, look, you've got 5 squared right there in the first denominator, and look at the LCD is 2 times 3 cubed times 5 squared. So what's missing there is the 2 and the 3 cubed, and so that's what you'd multiply by, is 2 times 3 cubed. And you do that same thing in the top and the bottom, 2 times 3 cubed. The second fraction, that's the second one, 2 times 3 cubed. So what's missing there when you compare it to the LCD? Well, the factor that's not there is the 5 squared. And so that's what you're going to multiply on that one. It's 5 squared over 5 squared, like that. And so what does this end up giving you? Now, I'm not multiplying this stuff out because I don't want to get hung up in the arithmetic here. And this is probably the last step I'm going to show in this problem because the numbers are kind of nasty here. But what I'm trying to emphasize to you is that now you've got the same denominators. Right? In the numerator, I have 2 times 3 cubed times 17. And here I have 7 times 5 squared. And now I could go ahead and subtract these two fractions. Notice I'm not multiplying this out because it's a big number. And that really doesn't serve our purposes here at all. You know, we could subtract it. We can now do the arithmetic. The arithmetic in the problems we're about to look at don't look anything like that, okay? But the method is what we're interested in. All right, so let's look at, let's see, problem number 196 in your book. This is, by the way, I'm on section 8.4, and this is page 934. And I guess actually instead of that problem, let's look at problem 190 first. And then we'll do the 196 after that. So let's look at problem 190. You have 1 over 12a cubed b squared plus 5 over 9a squared b cubed, like that. All right, so we look at the denominators. You know, the 12 and the 9, you need to find the LCD between 12 and 9. And at this point, with the 12 and the 9, if you can figure out the smallest number that both 12 and 9 divide into, then that's fine. And write that down off to the side. We're trying to build the LCD here. And so do any of you know what's the smallest number that 12 and 9 both divide into?
Would it be 3?
See, 3 divides into both 12 and 9. Now, you're answering the wrong question there. What I'm looking for is numbers that 12 and 9, those both divide into. So like 12 divides into 24, for example, right? It goes into 24 2 times. 9 divides into 18.
36.
Say it again.
36.
36. There you go. Very good, Anne-Marie. That's right. 36 is a number that 12 divides into, and 9 divides into also. And one way you could quickly come up with that is you could take the 12 and just start counting by 12s. 12, 24, 36, 48, and so on, until you hit a number that 9 divides into also. But one way or another, you get 36 there. And then we use what I've just been talking about in the last two problems. You use all the other factors that you see in the denominators. And the only other factors I see in the denominators are A and B. And then what do? You raise each one of them to the largest power that you see on any of the factors. So like an A, you've got an A cubed and an A squared. So the biggest power in A is 3. And for B, you have a B squared and a B cubed. So the biggest power you see on B is 3. And so that's our LCD. Remember, you use the biggest power for each variable. So you use the biggest power. All right, so now what do? Now you multiply by the missing factor, right? Multiply by missing factors here. So in my first fraction, just let's see. Yeah, I think I have enough room there. Okay, so let's see. You're trying to get a 36. So in that first fraction, you'd have to multiply by a 3. And you'd have to multiply by a 3 on the top. That 3 times 12 would give me 36. And then I have an A cubed, but the A cubed is what I have in the LCD. So I don't have any, there's no A's that are missing. But notice in that first fraction, there's a B that's missing because I have a B squared in the first fraction, but the LCD's got a B cubed in it. So I also need a B. And so that's what I'm multiplying by is 3B over 3B in the first fraction. The second fraction, 9 divides into 36 4 times. So I'm going to multiply by 4 and multiply by 4 over 4. And then what variable is missing on that second fraction in the denominator?
A.
A, that's right. I need an A in the bottom. That would give me an A cubed. And then I put an A in the top also. Remember, whatever you do to the bottom, you have to do the same thing to the top. And so now let's multiply what I've got left, or got written here, and let's see what I've got. So in the numerator, I've got 3b times 1 is 3b. And in the denominator, I get 36 a cubed b cubed. That's what I was trying to get. In the second fraction, I have 20a, and I get 36 a cubed b cubed. And boom, I've got the denominators the same. That's what my goal was to get the denominators to be equal to each other. And so I'm ready to add these two fractions together. And so you get 3.
If you already found the lowest, if you already found the LCD, why do you have to do all the multiplication on the bottom, on the denominator? Can't you just write that in?
Well, I'm actually showing the multiplication because that's really what's happening. Now, some people will just write down the LCD right away, but I want to emphasize, what I'm trying to do is emphasize here, Anne-Marie, that you're doing the same thing to both the top and the bottom. When you just multiply the numerator by something, the student kind of loses sight of the fact that they're really doing the same thing to the top and the bottom. And so I want to emphasize that, and so that's why I'm going to always write it out that way.
Okay. I thought I was just, yeah, okay.
Yeah, you were actually, what you were doing, I believe, was you were kind of skipping a step. You were kind of combining them. And that's and that's a common thing to see students do. I'm probably not going to skip that step, though.
That's fine.
Let's see. So, hold on real quick here. Okay, so what do I get here? I get 3b plus 20a over 36a cubed b cubed. And you'd be surprised how many students I would get will take 3b plus 20a and add them together and get 23ab. But 3b and 20a are not like terms. I can't add them together. I'm done with the problem. There's nothing to do here. These are not like terms right here, and so I cannot add those. So I'm finished. This is the simplified answer right here. All right. So let me work through another problem, and then we'll pause and we'll see if there's any questions as we go through this. So this is problem number 196 next. So 196, you have 7 over v plus 5 plus 9 over v minus 5. All right, so it's an addition problem. Denominators are not the same. So I need to get an LCD. I look at all the different factors. Now, in this case, there's no factoring to do in the denominators. So I'm trying to build the LCD. I write down all the denominators that I see, all the factors in the denominators that I see, and there's just 2 of them. It's just v plus 5 and v minus 5. And there's no exponents involved. That's my LCD right there. It's v plus 5 times v minus 5.
Why wouldn't you multiply it by -1?
I was just wondering the same thing.
These are not opposites of each other. Remember, I'm glad you asked that. Remember, opposites are in the form, let's see, let me write this down here. Opposites look like this. It's always a minus b and b minus a. So is that the way these are written? No. Look at the Michelle, the 5s have opposite signs, but do the v's have opposite signs in the original expression?
No.
Yeah, so you said this. So in order for them to be opposites, everything has to have opposite sign. So these would be opposites. If you had v minus 5 and 5 minus v, those would be opposites of each other. But v plus 5 and v minus 5 are not opposites because the v's have the same signs. Everything has to have opposite signs when you have opposites, right? And in this case, they don't. So that doesn't work to multiply just by -1 over -1. So I'm glad you asked that. To kind of, hopefully, I don't know if that straightens that out or not. Xavier, do you have a question?
Oh no, sir. I was gonna pretty much say, so with the question for the problem that we have, we're gonna just pretty much multiply it straight through to where it's v squared minus 5 squared.
Well, that's right, but you're kind of skipping a step in there. See, so what do you have to do? You have to multiply by what's missing. So in the first fraction, what do I have? I have v plus 5, but that's my LCD is v plus 5 times v minus 5. So what do I need to multiply by? Is the factor that's missing. And so that would be v minus 5 and v minus 5, right? That's the factor I need in that first fraction. Because what am I trying to do? I'm trying to get this to match up with the LCD. And see, so now this denominator matches up with the LCD when I multiply like that. And you're trying to do the same thing to the second fraction. What factor is missing in the second fraction?
V plus 5.
Good, good. So you have v plus 5 over v plus 5 like that. And see, so now the denominator matches the LCD. You're trying to get both denominators to match the LCD. And now they both do. And then whatever happens in the numerator, right? So in this case, you have 7 times v minus 5 right there. And in this one, you have 9 times v plus 5, like that. Right? And so now I've changed the problem so that the denominators are exactly the same. This is actually the exact same problem as the original. It's just that now the denominators look exactly the same. Now, I know that v plus 5 times v minus 5 is v squared minus 5 squared, like you said, Xavier. But don't multiply them out. Leave it factored. And the reason why you want to leave it factored is because you might be able to reduce it at the end. You might be able to cancel out common factors. But if you multiply it out, then you won't see that. So you always leave it in factored form like this. So now what happens here, you have the same denominator, so you can just leave the denominator alone, and then you multiply out the numerators. This is 7v minus 35 plus 9v plus 45, like that. Right? And then collect like terms. So that would be 16v plus 10 over v plus 5 times v minus 5. Now, there is a common factor in the numerator of 2. Doesn't do you any good to do that. You can factor it out if you want, but at the end, either one of these answers is going to be acceptable. So, all right. So let's look at a problem that's very similar to that one, and let's see how you do with this one, and then we'll see if there's any questions. Okay, so let's look at number 200. So number 200, you have 3z over z minus 2 plus 1 over z plus 5. All right, so there's no factoring to do in any of the denominators. And so we build the LCD. And we use all the factors that we see in the denominator. So that's z minus 2 and z plus 5. So that's our LCD. So now, let's see, I'm going to write the problem again right here so I have a little bit more room. So in the first fraction, what factor is missing in that first fraction? Anybody? What factor is missing in that first fraction in the denominator? Z plus 5. Yep, z plus 5. That's right. I heard both Michelle and Xavier both answering. That's good. So z plus 5 and z plus 5. That's the factor I don't have in the denominator on that one. And then in the second fraction, the factor I don't have in the denominator on that one is
z minus 2.
Z minus 2. Z minus 2. Right, so I multiply top and bottom by z minus 2 over z minus 2. All right, so when I do that, in the first fraction, I just get z plus 5 times z minus 2. That's what I'm after. Second fraction, same thing, z plus 5 times z minus 2. And then here you have 3z times z plus 5. And then here you just have z minus 2. And so now the denominators are the same. So I can go ahead and add the fractions together. And then I just multiply all this junk out in the numerator. So if multiply through by 3z, you get 3z squared plus 15z. And then in the second fraction, I get z minus 2. And then combine like terms. There's a little bit to do with like terms there. You get 3z squared plus 16z minus 2, all divided by z plus 5 times z minus 2, like that. And there is no way you're going to get a 16 from that 3 and that 2 in that last trinomial. And so that trinomial is going to be prime. And so this is our final answer right here.
Okay, where did we get the 15z from?
Right here, Michelle. So Michelle asked if for those of you who are listening to the recorded versions of this, Michelle asked about where the 15z came from. But remember, you're using the distributive property right here, Michelle. So 3z times z is 3z squared. And then
3z times 5.
Yep. Yep, 3z times 5 is 15z. So I was just multiplying that out in the numerator. Yeah, you're good?
Yeah, fine, sorry.
Oh, no problem. You're good. You're good. I know. This is the most questions I've had all semester, so I'm good. I'm thrilled. All right, so next problem. Let's see, I'd like to work at least one or two more here to make sure because there's a couple things I need to talk about for sure. This is problem number 218 on the next page. And so in problem number 218, you have 4d over d squared minus 81 minus 2 over d plus 9. All right. So first of all, it's a subtraction problem. So with the subtraction problem, I'm thinking, hey, this is a red flag problem. I have to be careful with the signs here. But also there's some factoring to do in the denominators. And so that's something you need to do before you go on and build the LCD. You have to factor the denominators. See, like in the last problem, z minus 2 and z plus 5, and then in the problem before that, v plus 5 and v minus 5, none of those factored. But in this problem, d squared minus 81 is a factorable polynomial. It factors d plus 9 times d minus 9. And so you need to do that. Otherwise, you will not be able to build the LCD. All right, so now we build the LCD off to the side here. And we write down all the different factors. So that's d plus 9 and d minus 9. And the most times that they're raised to any powers is just 1. So that's my LCD. It's just d plus 9 times d minus 9. All right, now notice that the first fraction in this problem already has d plus 9 and d minus 9 in it. So the first fraction, I don't mess with that one at all. It's already got the LCD. So you don't touch this fraction. So this one already has LCD. The second fraction, though, does have a factor missing. And the second one has a d minus 9 missing in the denominator. And so I multiply top and bottom by d minus 9 over d minus 9. And so this is minus, and you get d plus 9 times d minus 9 right here. And if you want to, you could go ahead and multiply the numerator out, you know, and it's probably not a bad thing to do here. So, and this is the same distributive property, Michelle, that you were asking about in the last problem. So, so 2 times d is 2d, and 2 times 9 is 18. So you get minus 18 right there.
I'm sorry, I have another question.
Go for it.
Where are we getting? Okay, the 49.
Where?
Oh yeah, because you were 40
Oh.
and then another one you were 49.
Yeah, I have no idea where the 49 came from. That's right.
Okay.
It's because yeah, ooh, man, that was bad. Yeah. My D's and my 9's get me confused there a little bit. So this should be 4D and 4D. Ooh, yeah, thank you for pointing that out. I have no idea where the 49 came from. So, Michelle, I'm attributing that to my age. I'm just getting old, and so I just, you know, I have trouble with D's and 9's and all that. So, all right, so now what do we have here? So you have D plus 9 times D minus 9 in the denominator, and then in the numerator, I've got 4D, not 49, but 4D. And then be careful, this is the subtraction. So this is minus 2D minus 18. Got to be really careful with the signs right there. And I put the 2D minus 18 in parentheses. And then you use the distributive property here, and you get 4D minus 2D plus 18. Notice how I changed both of the signs. And then collect like terms at the end. So you get 2D plus 18. Is that right? Yeah, 2D plus 18 over D plus 9 times D minus 9. And then the numerator does factor a little bit. There's a common factor of 2. Don't forget this step at the very end. And in this case, it mattered to do that because this fraction actually simplifies. Because the D plus 9s end up dividing out at the end. There's a common factor, and so you're finally left with 2 over D minus 9, like that. All right, does anybody have any questions there? Are we okay with that one?
Good.
Everybody's okay? All right, so I'm going to do one last problem, and I think maybe this problem will take us A little while to get through probably. This is problem number 238. One last example, and then I'll make some clarifications at the end, and we will be done. So you have p squared plus 4p minus 12, and then this is plus, and then over here you get 1 over p squared plus p minus 30. All right, so say that one more time.
I was saying, is there supposed to be like a 3 before the p?
Yeah, that is a 3 there. It doesn't look like a 3, but it was a 3.
Okay, I'm just making sure.
Yeah, oh yeah, yeah. All right, so what do you have to do? Factor the denominators first. So I factor the denominators. This first one is p plus 6 times p minus 2. And then the second one, it factors p plus 6 times p minus 5. This is, by the way, this is a very, very typical kind of problem that I might put on the exam as far as being the hardest problem in the group. They're not all going to look like this, but I typically will put one problem that might look something like this on your test. So what do you got to do? You got to build the LCD. And so to build the LCD here, you use all the different factors that you see. And in this case, there's 3 different factors. There's p plus 6, there's p minus 2, and there's p minus 5. So you end up having 3 factors in the LCD. Now the p plus 6 is used in both fractions, but it's only used once in both fractions. So that's all I need it in the LCD. I don't need it twice. Right? You only need it once because it's only used once in any individual fraction. So. All right, so now what factor is missing in the first fraction?
P minus 5.
Okay, so that's right. So I multiply the first fraction by p minus 5 and p minus 5. And in the second fraction, the factor that's missing is p minus 2. All right, and so now let's write down what we've got. In the first fraction, first fraction is going to be p minus 5 times p plus 6 times p minus 2. Second fraction, same thing. Exact same 3 factors. By the way, it doesn't matter what order you write the factors in at all. It's the same 3 factors, so if you wrote them in a different order, that would not be a big deal. And in the numerator, what have you got? You've got 3p times p minus 5. So 3p times p is 3p squared, and 3p times 5 is 15p. And in the second fraction, I just get p minus 2. And so then I'm done with that step, and I've got the denominators are the same. So now I add the 2 fractions together. And in this case, it's addition, so I don't care. I mean, I don't have to worry about the signs. It's not that I don't care. I just don't have to worry about them. So you have 3p squared minus 15p plus p minus 2. And then there is some like terms in there. You get, well, a little bit like that. And then you could try to factor the numerator here at the end, but there's no way that numerator is going to factor at all. So, so you're finished with the problem. All right. Does anybody have any questions about that one? So it's not too bad, but seeing if anybody had any questions.
Sure, I will later.
Anne-Marie, what?
I'm sure I will when I come to do this on my own later.
Oh, yeah, right. Well, the key here that I want, keep these notes out in front of you, but as you're working through these. But the other key is don't jump to the harder problems right away. Work some of the easier problems. And if I were you, I might practice problems out of the textbook before I even try to tackle WebAssign stuff, and we'll look at some of the problems that I assign out of the textbook. I think that might be something that you ought to think about. So, all right. So let's see. So we've got up through 8.3 and 8.4 done in your textbook, and so supposedly, based on your calendar, next week we're going to look at 8.5 and 8.6 on Tuesday. And then the exam starts up on Thursday. So I think what I'm going to do is kind of make a decision on the spur of the moment here. The way I had it originally on your review, I had both 8.5 and 8.6 both being part of your exam. But I think what I'm going to do is I'm going to include 8.5 on your exam, but not 8.6. So 8.5. And we'll cover both of these topics on Tuesday, but I'm only going to put one of them on your exam. So 8.5 is on complex fractions. And that's going to be on your exam. And then 8.6 on equations and solving equations. I'm going to not put that on your exam. Now, there are some questions on equations on your review. And so on the review, you want to ignore those questions on the review. So ignore rational equations. And I'll put a note on that, and I'll probably upload a different version of the review and actually leave those off or something like that. But ignore rational equations on the review. I'm going to go ahead and put that on exam 2. So that's actually good news for you because that means a little bit less topics on the test. And so only 8.5 will be on the exam, not 8.6. So yeah, that's probably going to be better that way. So okay. So anybody have any questions at all? Thank you, Sandra. Any other questions? Okay, then if there's nothing else that anybody wants to ask about, I'm going to shut it down for the day then. And so we will pick up with this again on next Tuesday. Remember, I have office hours Sunday evening, so don't hesitate to come by my office on Sunday evening, and then we'll have lecture next Tuesday, and then I'll be actually on campus next week, and so you can actually come by in person and see me if you have any questions there. So everybody have a tremendous weekend. Be working on your algebra. Remember that WebAssign homework is due next Monday, so make sure you get the Chapter 7 homework done. Have a great day, and I guess I'll talk to you later.
Have a good weekend.
Thank you very much. Thanks, everybody.
Thank you.
You guys are doing a good job. You're my regulars, so I really appreciate it.